Hello and welcome to the radio room. Today on the bench we've got a Hewlett-Packard 204C oscillator, primarily for audio oscillation. It covers between 5 Hz and 1.2 megahertz. Haven't opened it up, haven't done anything to it. It's been sitting for quite a while. We're going to see if it'll work, and we'll take a look and see what the inside of it looks like before we plug it in, and hopefully not have any fireworks when we do test it out. When we do get to test it out, we'll see if it's pretty close on frequency. We'll use an oscilloscope to do that. But let's go ahead and take a look at it. So here's the Hewlett-Packard 204C oscillator. I'll show you a couple of controls here. We got 6 ranges here in an off position. We've also got our main dial here, which allows us to tune it all the way around to 1.2 if you have it in the times 100K. So we'll see, we'll leave it right there. Then we have a little vernier dial here, and you can see it just does a little bit of movement there to help fine tune if you need to fine tune. And then variable output. This goes up to 5 volts RMS. 600 ohm output. It's probably pretty good for feeding into a radio. A lot of microphones are 600 ohm. And then a sync connection right here. The unit's in fairly decent shape. It's missing a screw here. I'm not sure if that's really the screw that's supposed to be here. Has something a little hot right there. A little dusty, a little dirty. We'll get it cleaned up. Bottom of it's got a nice stand on it. Kind of angle the front up. Ooh, that was kind of loud. Some feet. Let's look at the back at it. If I didn't mention before, this is a dual power oscillator. You can either run it off the battery, or you can run it off of 115 or 230 volts. It does have a selection of 230 or 115. It's currently on 115 volts. NiCad rechargeable batteries. I'm hoping the batteries aren't in there. If they are, we're going to remove them and take a look to see if they're exploded or not. And then we have a normal or low distortion switch right here. So let's go ahead and see if we can't open this thing up and see what's inside of it. Oh, let's see here. Well, let's start at the top. What do you say? And remember, always have your container for screws. Don't want to lose those. Take the top off, we got more to get through. So let's take a look at this for a minute. From the looks of things, it almost looks like, let's try to take the bottom off. Maybe it's open on the bottom and we can get through some stuff. A screw right here. Let's see what happens when we take it out. Gets us into another panel. Okay, well, not making much progress here. Let's try in from the sides. Hoping these new videos that I'm doing will be a little bit better than the last series I did. The last series were recorded strictly off of my phone. So it was a little hard to do actually working on stuff at the same time. Look, they don't make it easy to get into these things, do they? But now I do have a camera set up on the bench using a little better microphone now, so hopefully this is going to come out okay. I really wanted to make it so y'all could see what I was actually doing on the workbench without having to hold a phone. Sometimes I need both hands, and sometimes it's hard to get a phone to just sit in the right place. So we've got a little bit different setup here, a little bit more lighting. I might have to play with the lighting a little bit more, using some different software on the computer instead of just running through the phone. Oh look, well, we do have lots of adjustments here. We got automatic gain control and frequency calibration here, high frequency calibration, B+ voltage. These look like test points. So bias test points, distortion, automatic gain control, and bias control. That's probably for the amplifier. Let's see what happens if we take this off. From the looks of this, these are separate from the front. Well, that's promising. Things are loosening up a little bit. Hopefully everything doesn't fall apart on us. Nothing like trying to hold an entire radio or piece of equipment together while you're trying to put everything back together. Okay, well, we're getting there. Let's take that other side off and see what happens. I have downloaded a manual for this. Surprisingly enough, it does not include how to disassemble it. It is a service manual, and it tells you plenty of service points. A lot of different points to check and what values they need to have. Surprisingly enough, they do not tell you how to take the case apart. So we're just going to go through this together and see if we can't get into it. You know, that doesn't look like it's holding anything. Oh, now we're loose. Okay. Well, first off, there's no batteries in it. I'm glad to see that. This thing's been sitting in a shed for quite a while, and I was hoping there wasn't any batteries left in it. Well, isn't that nice? That's nice. I like that. It's got a nice contact board here, connection board here, so you can remove that back. Everything on here is looking pretty good. We got our power select switch here, a charge rate switch there. This looks primarily like it's just the mostly power supply. And the board just comes off as one piece for the power supply. Okay, so let's take a look at this thing. See if there's another way. It's got good shielding. That's good to see. Not really sure how we're going to get into and look at anything else. There is a few components in there. I'm trying to look at some of the capacitors. Sometimes when this stuff's sitting for very long, those capacitors can start leaking. And by leaking, I mean two different ways. One, physically, having their goo come out of the inside of them. I'm not seeing that on the ones that I can see. I think we really need to see if we can't figure out a way to get into this to find out what everything looks like. But this thing is pretty tight on how it's put together. Trying to see if that front wants to slide off like the back did. It doesn't appear to want to. So, well, you have a variable capacitor in there. This has a Wayne bridge oscillator in here, followed by an amplifier. It uses the different resistance values on the range select here to help determine that, in combination with this variable capacitor. Wow, this thing's well, let's just see if we can take some more screws out and see if it'll actually come apart. I really don't want to pull a part off and the whole thing come completely apart. Pardon the screwdriver right in the camera there. Let's see what that does, see if it loosens things up. Okay, that loosens some stuff up. Now, what do we still have holding it? I'm going with the knobs. That appears to be the only thing really holding us at the moment. So let's see if we can't get these knobs off of here. Well, it almost looks like somebody's put some rubber or some RTV or something in these holes where the set screws are. Let's see if I can get an Allen wrench and get in there. Maybe see if we can't get these knobs off of here. See how things go from there. Looks like they're probably going to be pretty small. Doesn't act like it really wants to play very nice. Let's try the other one. I'm doing this by feel. Like I said, there's some sort of goo or something in the... I don't know if you can see that. In there, it's almost like some sort of rubber or something is in the hole. See if we can't clean that out and see what we're looking at here. Hoping this is the right size. Well, this one's exposed. Let me see what the size is here. Let's try the other end of the Allen wrench. I'm sure you can see that, but my world-class Allen wrench set has a deformed Allen key. I know this fit in the other one. I would hope they're not going to try and surprise us and have two different sizes. So wondering if that rubber or RTV or sealant is getting in our way here. Sometimes you never know what you're going to get into. Some of this older stuff. Oh. Well, it feels like it's wanting to. I don't know what anybody's ever done. This might not be the first time somebody's had this opened. And I'm serious, that looks like somebody literally stuffed our TV in there. Perhaps the manufacturer, maybe Hewlett Packard put it in there so you didn't see the set screw, maybe? Almost acts like it wants to go in there. Just not quite doing it. And the same thing on this one. So I'm thinking that's maybe something that's from the factory. So you didn't see the set screw. Let's see if we can't get some more of that out of there. We can see what we're doing inside that hole. Okay, now I'm starting to see the set screw inside there. I'm not sure you can see that right there. Well, if I got it in the right spot, you might be able to. And you can just start to see that Allen screw inside there. And it's full of stuff too. So let's see if our Allen wrench will go down in there. I'm going to laugh if you don't have to take the knobs off to do this. Oh, that one loosened. That's always good. Sometimes I hate undoing an Allen screw, especially if it's this small. Seems sometimes you're just fighting either bending the Allen wrench or trying not to strip it out. If this is original gunk or rubber or RTV or whatever, because these knobs probably not been out since it's been made. If that's the case, we're looking at 50 years. I'm gonna guess. The manual I downloaded was copyrighted in 1968. But it included this model, which is the C model. The C model. Also included the D model. This being the C model, this may be closer to early 60s, possibly. It is all solid state, there's no tubes. The amplifiers are solid state. So, guessing it probably doesn't go back too far. Okay, you know what I'm going to do? I'm going to go ahead and set this to minimum. That way when I put the knob back on, I can kind of locate it in the same orientation instead of having to guess where it's at. Wow, this is going to be a lot of work, and I'm probably going to find out I don't have to take the knobs off to get the front off. What do you want to bet? Oh, I'm starting to see some metal in there, so that might be a good thing. I'm starting to see that set screw in there. Nope, not catching in there yet. I know y'all are probably thinking, oh, we want to see the insides. We don't want to spend all this time looking at you just fighting with this. Well, that's part of the fun. Figuring out exactly what you got yourself into in doing this. So, got a little bit more of it out of there. Let's try it again. Really don't know what that stuff is, but wow. Hey, look, the knob comes off anyhow. Only had one set screw really holding it. Now, let's just take a look at something. Yep, that's moving the shaft too, so we might be able to get this front off. If we can get this other knob off. And we might have to take the big dial off as well. We'll see. Get this stuff out of here. And perhaps maybe Hewlett-Packard put this on here to see somebody has gotten into it. It's perhaps the only way you can get into it is to dig this stuff out. And if you dig this stuff out, that means somebody's been in it. And they come after you and go, why has somebody been in here? Well, maybe it needed fixed. Well, the nice thing about this, and I've looked at the circuit schematic, it does have a few things that can fail inside of it. There's some transistors, capacitors, resistors. That's pretty much all that's in this thing. I think there's 3 or 4 transistors, mostly on the amplifier stage. The oscillator side of it is mostly capacitors and resistors. So if you're interested in how this thing's working, probably the best way to do that would be look up Wayne Bridge oscillator. See if we can get this Allen key in here. Now let's try the other one. As soon as I find it. Behind the dirt. I want to see what's inside this thing. Even if there's nothing that we end up having to do on the inside, I still want to see what the inside looks like. Ah, that one's locked. Ah, broke free. Yay. Still doesn't want to come off of there, so it looks like we're going to have to get the other one cleaned out as well. If we can't get our Allen key in there. Get this knob off. And then probably find out it's not going to get us any closer. But we'll see. This may turn out to be the boringest video ever of me trying to get into this oscillator. Ah, right. Okay, so that knob's off. Let's see what she likes now. Oh, still got something. Oh, very nice. Very nice. Got a wire holding us up here. There's that wire going. Looks like she's soldered in there, guys. Yeah, she's soldered in there. The green wire right there, holding us up. Let's see if I can get some better light on this. Right there. A little dirty inside, not too bad. Same sort of deal on the front here. Contacts slide into a little deals there to make contact with the front. Well, maybe we'll just unsolder that wire. You can always solder it back. The old soldering iron heated up, and we'll be right back here in just a few minutes and see if we can't get in there and take this front completely off. Okay, we're back. Had to take a little pause there. I'm missing a tip for my soldering iron. I got some extra ones. We'll go through and talk about that in a little bit, but I do have the one I need on the soldering iron. It's a chisel tip, as they call it, and we'll see if we can't pull this wire off of here and pull this out. A lot of weight here, so I might have to turn the soldering iron up a little bit just to. Looks like they wrapped it. Yep, it's wrapped. So we're gonna see if we can't get some of that solder off of there. I'm going to use a solder sucker. And I'll make a video in the future about this little guy and some other soldering tips. No pun intended. We got a little bit off. Put a little more solder on the tip. Get a little better heat conduction. Get a little more heat going too. We can't get that out of there now. And this might be something we might end up cutting this. You can see how it's moving around in there. I just wrapped it around that. Add some more solder. Can get that loose again. Alright, we're free. Now if you'll notice, I know it seems counterintuitive. I was actually adding solder to it. Two reasons. One, the little bit of rosin in the solder helps clean things up while we're going. 2 gives a lot more surface area. It's actually wrapping around the solder joint in there and transferring that heat to the solder joint a lot more efficiently. It's not just a little pinpoint of contact on that. There's actually liquid solder wrapping around in there and moving that heat into the solder on the joint. So let's see what happens now. A few more wires at the back. We could unsolder those too. I'm really just wanting to take a look inside here and see what we're dealing with. Find a spot this wants to sit. And this is our main variable capacitor. Go ahead and turn it so you guys can see how it's working. Just an air capacitor. Almost looks like it doesn't go quite far enough. Let's see how it meshes here. Looks like the front knob might be off just a little bit. We don't have full mesh right here, and I'm willing to bet that that's probably supposed to be fully meshed. And that's all the way down. So let's take a look at what else we got in here. Looks like we got a Sprague capacitor in there. 30 microfarad. Looks like maybe a 10 volt. Couple of ceramic capacitors. Lots and lots of resistors. Couple of potentiometers along this bottom side down in here. Make sure you can see that with my hand getting in the way. See if I can find something to point with. Some variable capacitors right in, or variable resistors right in here. Potentiometers. Right here. Get this wire out of the way. You can see our wafer switch that's got all the various resistors that help form the range. A whole line of, get some light in here. Whole line of transistors right in here that probably form the amplifier section of the oscillator. If I had to take a guess at this point. So I'll just set this carefully back in here. We'll take a look at what the rest of this thing looks like on paper. This right here is the main board, the actual oscillator itself. I don't really sure if y'all can see that real well. Try to change some light here. Maybe that'll help a little bit. In this area here is our bridge. This is all the Wayne bridge right here. This is power coming in from the power supply board. That was the back panel of the unit. We have positive 13 volts and a negative 13 volts. coming in from A2, it says, which would be the back panel. We got negative 13 volts here, positive 13 there. These two connect here. Feed through the resistors. All these resistors are the ones on that front switch where we had our wafer switch. They changed the resistance in the Wayne bridge oscillator in combination with the variable capacitor right here, which is that big air capacitor. We got AGC and frequency calibration right here. This fine tunes the capacitance in that oscillator. After it's made and forms the signal, it comes in here and starts going into the amplifier stage. This is an amplifier stage and wave shaping. That's what helps give us clean up and make sure we got a nice pure sine wave. We have our AGC section down here. This is what's making it so that it maintains the proper amplitude and keeps everything synced together. And it looks like right here we got two transistors that appear to be in a push-pull amplifier right in here. You see positive here, negative here. This is our control, that output. The sine wave comes through here, and then we have our amplitude control. That was that front knob that we had on the front panel. Looks like it has two variable resistors in it, one on the ground side and one on the positive side, for lack of a better term. Feeds it out to the two binding posts that are on the front. This one being grounded, this one being active. And together they have a 600 ohm output. And this is the front switch. It's got numbers right here you probably can't read that correspond with these right here and right here in order to get the multipliers. So this is basically a frequency multiplier as far as the resistance side of the Wayne bridge oscillator, which is basically just an RC oscillator, resistance and capacitance. This is the back panel. There's actually two different schematics here. Turn this the right way so y'all can look at it. This one right here is the one we have. You'll notice, and I don't think you can read it, this did not come out very big. There's actually 4 batteries right here. So AC comes in. This is the plug. Comes through our transformer. There's a switch right here to change which windings on the transformer the primary side of the transformer is going through. The two wider ones would be the 230 volts. I'm not sure you can see this, but the two more inside windings are going to the 115 volts. Goes through the transformer and steps it down to, just from looking at this, I'm going to go with probably 33 volts. We got a 33 right here that is tied to one side. This is a bridge rectifier, full wave bridge rectifier. It's got 4 diodes in it, so as the current's flowing one way, it can go through there, and then it gets blocked by the other side. But you see how we have 2 connections here. So if the current's running this way, then it can go on the positive cycle. That makes this flow out there like that, a positive. And then if it's, once the cycle, the 60 hertz cycle, the AC comes back, it doesn't let that go this way. Now I'm using current flow is subjective. There's two types of current flow. There's electron flow, and then there's normal everyday electrical flow. In a normal everyday electrical flow, conventional flow, the flow goes to the positive, flows down the positive. In electron flow, the flow is actually the other way. And as the diode here, you can see this would be the negative side, and this is the positive side. See the little line right there? I'm not sure y'all can see this or not. I might have to get a better drawing here. Let's see if I can just draw this out for you a little bit bigger. So maybe you can see it if I can keep from breaking the lead on my pencil. I'll get a little more light on this. Draw this a lot bigger for you. Tried to draw that one backwards. As you can see in here, current can only flow one direction through these diodes. That's how it rectifies it. It turns the AC into DC. So this is AC over here. Coming out of this is going to be our DC. So the voltage out of this is going to be basically the same as the voltage in. We're going to have slight loss through the diodes, probably around a volt maybe. So as we're coming through here and we go, say, positive on this side, it's getting blocked. It can't go this way, so it can't get to this. It can go through here and come out this way, but then it's blocked by this one. So the only path for the positive to go is out this way. Now when it circles around and this side's now positive, it comes this way, it can't go this way, so it can't get to this lead, but it can go this way and goes to positive again. And that's conventional flow. If you look at this the other way around, electron flow, then this is always the negative side. The side with the line on that diode. So this takes, right here, takes our AC and turns it into DC. After we come out from there, we have our negative 33 volts here. We have our positive 33 volts here. But right in oh, I'm sorry. Let me take that back. That's our B positive right there. I'm sorry. I was looking at that backwards there for a moment. But right here, looks like we have a regulator, which is sending out and regulating our positive. And it's also being controlled by our negative right here. It's actually controlling the negative side of the power supply to maintain our reference voltage, 33 volts between the two, with a common point center in right there So this is actually negative 13 volts and positive 13 volts, and it's regulating it at 26 volts. And these are our batteries right here. This is part of the charging circuit right here. And then this helps control how much current is allowed to flow through there by this transistor. And that comes over and meets it right here. And I'm sorry, the explanation was a little rough on that. If you thought it was hard to see, it was pretty hard to see even on this end, so I was trying to look through that schematic. It would have been nice if it was a little bit bigger. But that's what we've got right now. And I still got to work on doing these videos a little better. I could have been a little bit more properly prepared. There's not a lot of electrolytics in here that I'm seeing. As far as capacitors, a few. Let's hope they haven't dried up. Let's hope that they're not leaking. And by leaking, I don't mean just physically oozing stuff. I mean leaking current, which basically kind of turns them into a resistor in the circuit. We do have an electrolytic right here. That one. I don't see any damage. What we're probably just going to do, see if we can't put this thing back together and plug it in and see if it works. If those are leaking, it's probably not going to work, or it's not going to be very stable. But that looks to be mostly the amplifier side of things. So we'll see if we can't get this wire soldered back on there. We're not going to loop it through. We're just going to get it and tack solder it on there. That's really all it needs. And this has been like that a little bit. I'm going to get a little bit of flux. Got some soldering flux here. Just helps clean things up. Gets contaminants off of the surfaces. Just going to get a little bit of solder on, or a little bit of flux on that. Maybe just a little bit on the wire. That'll help our soldering process a little bit better. Clean up my soldering iron a little bit. I'm going to re-tin it. I'm probably going to clean it a little bit better. So we're going to get some solder on there. The flux in the solder will help clean it a little bit. I'm just going to get a whole bunch on there, and then I'm going to clean it off. And immediately re-solder it, or re-tin it. I always want to make sure we keep solder on our tip. Keep it from oxidizing. Keep it from not lasting as long. So we got a little bit of tinning on there now. And we're just going to basically kind of contact solder it to this. Right like that. Right back through the hole. And now, clean my soldering iron off again. Make sure it's nice and clean. Get it re-tipped as quickly as possible. Just keep plenty of solder on this thing. I'm actually going to put it back in the holder and turn it off, so I just make sure we got plenty of solder on there. Keep it sealed. Makes your tips last a lot longer. And let's see if we can't get this thing. You know what? Why don't we take a little bit of compressed air, and we'll just kind of blow it out a little bit. Hoping that's not too loud. Still figuring out my audio and video stuff. Don't really know how this sounds until I go back and review the video and do the editing. So y'all are kind of along for the ride on a little bit of an experiment. I'll go ahead and loosen this front up a little bit, see if we can't get that capacitor fully meshed. Just guessing this is the same size. I don't think it is actually. I think those are actually bigger. Yep, those are actually bigger. So let's see. Maybe this one? I think that one might be actually a little bit too big. Well, I know it's got an Allen screw in there somewhere. There's two deals on there. Just gotta see if we can't find the. Oh, got the right one. So I'm just gonna loosen this. You know what? I might pull it off. I might take a look at the shaft and the vernier adjustment. See what they look like. As old as this thing is, it might be a little dry. Oh, now we're locked in. Okay. So I'm going to go ahead and pull this off. Well, that's certainly looking a little dry. Now this just slides in here. I don't know if y'all could see that. That's just up against that spring. It just pushes out so you can make fine little adjustments. Wow, that's dirty. That's a little dirty in there. We're going to clean that out. Might put a little lithium grease on this shaft. Also seeing actually some metal shavings right in there, it looks like. So we'll get some stuff and we'll see if we can't clean that out a little bit. Yeah, that's dirty. Lots of sand. This thing has been, well, in a shed for 10 years that I know of. And who knows how long it's been since then, since before then. Probably going to get just a little bit of something else that's got some liquid to it. Break out the old trusty Pledge wipes. See if I can't clean this out a little bit better. See if we can't get into that through here. Clean where that shaft goes through. This is pretty icky. Twist that around in there, see if I can't get it to clean out a little bit. We'll put some lithium grease or something in here to help lubricate this. Not terrible. Inside of there, but this little recessed area is pretty nasty. Sometimes when you're working on older stuff or stuff that's just been stored for a while, gets dust around here, gets a lot of sand in it. The shed that it was in is not exactly climate controlled or sealed or anything. That's looking a little better. And there's something a little bit finer. I'm willing to bet that's probably dirt combined with really old lubricant. Clean this up around here too. Not really sure we want to try and take that gear apart. Might just gently drop some oil into it. Sometime in the future we'll come back in here and do a full restoration on this. But I'm more curious just to see if it's going to blow up. See if it works. See if it's anywhere accurate. Of course, we'll also get an opportunity to see if my oscilloscope's working right too. It hasn't had a really good test. Played with it a little bit. Haven't had a chance to really work it out. Gonna have to do some cleaning on it as well. Had to take a little break there when the better half says dinner's ready. Well, you better get it. Don't want to miss out on that. So we got it pretty much cleaned up for as much as we're probably going to look at it right now. I'm going to go ahead and get some lithium grease. Maybe put it around that shaft. Get that cleaned up a little bit, maybe more a little bit. Almost feels like it's got just maybe a little bit of lubricant left. We'll get this cleaned up as well. Get that sand out of there. We don't want to mix that in with the grease. We don't want to grind everything to pieces. So I'll just get another trusty pledge wipe out here. These things, I love these things. Strong enough to break stuff up, but I have not found anything that it'll hurt. Dries pretty quickly. Good for cleaning stuff up. Make it pretty again. Let that dry off a little bit. Just cleaning off the face of this a little bit before we get the knobs back on there. Oh. That one didn't exactly want to unscrew there. It mostly just lost the tip of it. We'll see if we can't get that back on there here in a little bit. Same thing with this one. It used to have a cover like this. Not really sure what happened here. Somebody got a little medieval with it. So. Probably put some glue or something on that later. Get it to stay better. Kind of slipping. But this thing's 50, 60 years old. It's allowed to have a loose knob or something. So let me grab some little lithium grease, and I get a little bit of oil, light oil. We can put on that other shaft. Hopefully my lithium grease is still in decent shape. We're just gonna apply a little bit of lithium grease. Cotton swab. Don't want to put too much on here. We just want to get enough to lubricate it a little bit. Don't want to put so much on there that we're catching a lot of dirt and stuff. That should work. Now, I'm going to go ahead and fully mesh that variable air capacitor as much as possible. And we'll put the front knob back on. Make sure we got the right Allen wrench this time. And we wipe it off a little bit first too. Now, I'm going to try and line it up right there. Get it lined up. Hopefully I grab the right Allen wrench again. And tighten her down. All I gotta do is get it lined up again. Oh, there, we're in. That's back on. Get this out of the way before we make a mess. This lined up. Now, let's see if I can get this good enough. You can probably see those contacts down in there on that board. They've got to line up. Get lined up with that. And our board's is lining up with it now. Slide them back in. Clean up our knobs a little bit while we got them off, and they're easier to work with. Had this off, so we'll leave it right there. Okay. Had to take just a quick break there. I know you probably can't tell in the video, but it's time for the kids to go horizontal, check their eyelids for pinholes for the night. Had to Go see them off into bed. And the youngest has instructed me that one of her stuffed sheep needs to come and help. So Pinky is going to help us. Pinky's going to sit off to the side and help us. Yeah, she might sit over here. Keep an eye on us, Pinky. Alright, we had this thing turned off, so I want to make sure I line this knob up with off. It feels like it'll go all the way against the faceplate. We don't want it all the way up against the faceplate, so I'm going to lift it up just a little bit so it doesn't start scratching it. Find that set screw again. Through the black gunk. Oh, that's right. World class Allen wrench here has a messed up end, so we got to use this. Oh, we just got to find that thing again. Maybe we'll find it and then put it on here in a minute. Okay. Lined up with off the faceplate just a little bit, and then we'll tighten her down. Make sure we get the other set screw as well. Okay, now before I had minimized this one, there's not really a lowest mark that we need to line up on. There is a maximum. It's a little line right here. So I'm going to set that in maximum. Because see, this is not a keyed shaft. It's not a flat-sided shaft. So this thing can really go on there any direction. But it does have an arrow. And if nothing else, I want to make it sure it looks like at least that arrow's doing something. At least at some point corresponds to some sort of value. I think I'm going to see if I can't figure out this one set screw while we got it off. The one we couldn't really loosen before. Maybe this will be a little easier without a bunch of getting that gunk out without having to have it up against the faceplate. So let's see if we can't clean this out a little bit better. Get that one set screw that we never actually loosened. The knob just happened to come off. And cleaned out a little bit better. Oh, it's got a lot of gunk in it. But we're turning that one. You know, I'll bet you this is the one that we got last time. Yeah, that one's working real good. So, do the same thing with this one. We get lined up with about that mark. Have us lined up with this ridge here, so get our Allen key set. Line it up with the 5-volt RMS mark, the only mark we got to go off of. Tighten it down a little bit. Now that slipped down a little bit. I want just off the faceplate, just a touch. Let's see if we can get lined up with this one. And tighten it down as well. Yeah, that feels good. And that looks like it's pretty much in the same spot it was before anyhow. So we'll get these out of the way. For the time being. Open this thing up a little bit more. And sit and collecting dust for a few years. Our workspace up a little bit. See if we can even remember how to put this thing back together. Okay, we'll start with this one right here. Alright, take a look at this power supply. Do have an electrolytic here. Another one right here. Physically, they look good. No bulging, no leaking. Hopefully they're still in good shape. Everything looks actually surprisingly clean for as long as it's been in storage. So it must seal up pretty good. See if we can't get it back on the back. Like that. Clean this back panel off real quick while we still got things kind of out of the way. You know, most of what's on here is really just loose dust. This thing's actually quite clean. Not a lot of grime on it. Also just needs a dusting. Okay, so see if we can't put this back together. For some reason this had these little star lock washers in here, which, to tell you the truth, I'm not entirely sure they're original, or if they are, somebody's opened this thing up before and apparently lost the ones on the other side, because I did not notice them on the other side, just this one side. Got another one hiding in here somewhere. I thought. Perhaps not. Oh, screwdriver got away from me. Screw got away from me. Alright. Sides a little white down. Get the dust off of them. Well, really, this oscillator, unless you actually really had to go in and do some major work on it, it's quite nice. And literally, you just figure out a way to lift the panel up and you got it off, and you got all your adjustments right there. I'm going to put the other side on. So he has a rather clean device for its age. And for where it's been for the last 10 or 12 years. Found that screw. Thinking that was on this side. The one with the star washer. I thought there was 4 of them on this side. Apparently there was. It was hanging out on one of the screws. This one right here. Got that star washer on it. Yeah, I find it really interesting. These feet are designed to come off. Just a little push and a button and a slide. dusty one. So this one, I'm thinking this one screw, I think that screw that's supposed to be here is actually supposed to be more one of these. Another reason why I think this has been opened up. We'll put it back in the same spot. Not really sure where that screw is supposed to be at if it doesn't go there, but or maybe we're just missing one. There she is, all put back together. I think I'll work on getting something set up, hook this up to, see if we can't turn it on, see if it does anything. Perhaps we'll hook it up to a speaker, see if we can't listen to it first. We'll make sure we turn this down first before we do that. Don't want to flip the switch and go deaf all at the same time. So, let me get some stuff ready. Oops. We'll glue that back on too. We'll get some stuff ready so we can do some testing on this. Make sure everything's going to work. And hopefully, we'll have an oscillator oscillating. Good morning. Taking a break overnight, went to sleep, got some sleep, got up this morning, decided let's see if we can't test this thing, see if it even works. We'll turn it on, make sure the magic smoke doesn't come out. Got it hooked up to an oscilloscope, pardon me, and a frequency counter. Got the oscope hooked up here and the frequency counter here, and their respective grounds hooked up to the negative side of the output. So let's go ahead and get to it. See here, I got the oscilloscope set up. See if I can make this a little bit easier to see on the screen. I don't have the perfect camera angle right now on this, but we'll see if we can't make this work. Frequency counter set in kilohertz, and the oscope ready to go. Let's turn the switch. First off, let's do the smoke test. Okay, no buzzing, no smoke, no melting. We're good so far. Let's go ahead and get some, check some ranges here. Through the ranges, and no weird sounds, no smoke, no nothing. Alright, so I got it in the times 100 position. And we'll move over to the oscilloscope. take a look. Well, we got a signal. Let's see if we can get this. Can do something we want to do. I think this is more of a O-scope problem right now than anything. This oscilloscope is pretty old too. It's having a triggering problem's the main problem right now. Oscilloscope is not playing nice right now. Let's try a different frequency range. See if we can get it to... see, now we're getting somewhere. I think we got a dirty contact on the trigger. We'll just do some manual triggering. Well, it's not too bad on the triggering. The oscilloscope's starting to cooperate with us a little bit. Right now I'm in the times 1K. I got the dial set at 2. You can't see that right now. But we are showing real close to 2000 hertz or 2 kilohertz. Just a little slow on that. I am noticing on our scope we do have some flat topping on the bottom here. So it's on one peak. That's a fairly nice sine wave aside from this flat topping on the bottom. So I'm saying it's working. Let's try some other frequency ranges. I'm going to move up to times 10K. That should move us to 20 kilohertz. And we're within 500 hertz of that. Still having our flat topping. Now let's move up to times 100K. So this should have us at 200 kilohertz. We're about 4 kilohertz off on that. It's trying to even out that flat topping just a little bit. A little bit of jitter there. Let's try turning the frequency up. Let's go to 300 kilohertz. Got a little more error on our frequency. 400 kilohertz. 500 kilohertz. Trying to get this cord out of your way so you can see the frequency counter. Maybe it was better where it was. 600 kilohertz. Starting to run off a little bit on our frequency. 700. Yeah, it's getting pretty laggy there now. 800. 900. 1 megahertz. And we're down about 300 kilohertz right there. I'll move this over to megahertz, you can see that. About 300 kilohertz low at the 1 megahertz. 1100. Not really coming up. Not a lot of difference there. And what's supposed to be the max on this, 1.2, which we're nearly 500 kilohertz low on that. So it's got a few issues. I'm going to turn this back down. Go to 180 kilohertz. A little low there. And let's just go down to 100. I start getting down there and it's not quite as bad. Let's go to the times 10K. Get that better on the oscilloscope. Still have our flat topping. That right there should be 10 kilohertz. Yeah, a little off. Let's bring this up here. Let's go to 2.5 kilohertz. It's a good audio signal, audio frequency. About 2,000 hertz low on there, about 2. Oh, I'm sorry. That's 2.5K. And still have that flat topping. That's not a nice signal. I'm not even sure what that would sound like. Maybe we'll try in the future sometime hook a speaker up to this. I'd really need to build an impedance bridge to match the 600 ohms down to the 8 ohms a little bit better. And our amplitude switch is a little dirty. As you can see, it's a little jittery. It probably could use a good spray. And this is just about halfway on the amplitude. Let's see. That's full bore. I think my oscope's a little off here. Let's try this. That's full output. And that really shows that flat topping right there. The top of the signal is nice. It's beautiful. We're gonna have to take care of that. And that could be in the bias control on the feedback of the Wayne bridge. Getting a little funky right there. We could also have a capacitor that's a little out, throwing things off just a little bit. Possibly a resistor's a little out of value. But we know it works. I mean, at least it does come on. And it's not terribly off frequency. So I'm going to call this a win for just going through and making sure nothing appeared blown up on the inside and everything looked good. Just needs a little tweaking, I'd say. So we'll probably do that in a subsequent video. Go through and see if we can't align this. I'm going to study the service manual a little bit, see if we can't get some ideas. I've looked at it briefly, and it looks like the bias and the frequency shouldn't be too hard to adjust. The bias is just some voltage measurements, and setting the frequency is just setting the machine up in a certain way, certain range, certain frequency, and using the frequency counter and adjusting it. There's a regular frequency adjustment on this. It also has a high frequency adjustment on it, so that might be what's going to fix this. But right now that should be 250 kilohertz, and we're about 19, 18 kilohertz low. And as you can see, that does get worse as we go up. That should be 600 kilohertz, and now we're down 40. You get up to the maximum operating range of 1.2 megahertz, and we're nearly 300. So there's some problems in there, and we'll take a look at those, see if we can't fix that a little bit. Probably in a future video. Just wanted to kind of go through with y'all about the HP204C oscillator. It's been sitting for quite a while. See if it even worked. And it appears to oscillate. So thank you for going through this experiment with me in more than one way, seeing if this is working. And this is the first video with the new setup. Still got some tweaking to do. Like I said earlier, it's an experiment, but I'm glad y'all went for the ride with me. Hope it wasn't too rough. We'll see you later.